Well, by now you've seen a number of types of applications of Delphi functions in terms of string functions specifically are to do with separating things out and isolating things after a comma or whatever it happens to be. Typical applications is counting how many words. If you think about it, if you go into a word processor, it tells you as you add words, at the bottom of the screen tells you how many words there are. So there's obviously some type of algorithm involved. And it can be quite complicated in actually determining what, although it might be obvious to us as human beings, but to determine how many words there are in a sentence. So for our purposes, because sometimes there might be commas and this and that, and it's actually quite difficult to specify, although as human beings we do it very easily. So the definition in terms of this particular example is we're going to say that a word is something that is separated by a space or a hyphen. So this and sentence are two words, and multiple dash words are two words. It's a little trick involved here that need to, because this says this sentence is multiple words and there are 10 words. Okay, so let's count all the spaces. One, so that's one word, two words, three words. Also going to count that, so 4 words, 5 words, 6 words, 7 words, 8 words, 9 words. But there are 10 words, okay, and it has to do with this last one, okay, because there's no space after it. So you might say, okay, well, then I must just check for a full stop. But it could be a question mark, it could be an exclamation mark. Okay, what we're going to do is we're going to do a little bit of fiddle, and we're going to say, right, we'll just remember to add on 1 every time. Okay, because if I go by that algorithm, I say, right, well, I need, every time I pick up a space and every time I pick up a hyphen, it'll mean there's a new word. Okay, but that unfortunately say that space picks up the 10, but there's no space after words to pick that up. So that's why we're always going to be 1 out. Now I need to discover that when I wrote the program, and I haven't read the question properly. Okay, typical teacher. Okay, so store the answer in a variable called iCount. So essentially what we want to do is we want to, okay, that's our sample sentence, for example. You don't need to know that, okay, so that's what the sentence is. Okay, S sentence, sorry, that should be S sentence there. Okay, but again, that's just an example there. That would have been input by the user or whatever it happened to be. iCount equals 0 because I want to count a whole lot of things. Again, standard thing. For I loop equals 1 to the length of whichever string variable I want to go through. I want to look at all the characters. Again, standard. If sentence, the name of the variable, I loop. In other words, it'll be 1, 2, 3, however many characters there are in that sentence. If those characters are in this set, there's a space there and there's a hyphen, then increment the count. Okay, we've done that with a few things. We've had that .9 or AEIOU or okay, so we can check for whatever occurrences, whichever characters that we want. And we could also use the pos function as well, but this one just seemed to be easier to do it that way. Right, and here's my fiddle. Show that the number of words is equal to int string count plus 1, because we know it's not going to pick up that word at the end of the sentence. You might say, well, that's cheating. It's not cheating. It's actually just modeling what's happening in the real world. That's why sometimes to write a program to actually analyze how many words there are in a document is not that easy, because sometimes people use double spaces by mistake. But our one was very specific. We said, right, as soon as you get a space, as soon as you get a hyphen, it means that's another word. Okay, but we know, in fact, the last word doesn't necessarily, well, certainly won't have a hyphen and won't have a space after it. Okay, and so we could check for question marks and full stops, but there are other things like exclamation marks, etc., etc. So we're just excluding that from our particular example. But again, standard structure, go from 1 to the length of this, look at each character. If it's in there, increment the count, show message, number of words equals plus, okay, into string because I need to convert it to a string, and iCount plus 1. Okay. Or alternatively, what you could have done in the beginning is start off iCount equal to 1, knowing that there's going to be 1 extra. Okay, that could have been another way of doing it. Right, our last one is going to, right, our last and perhaps longest example is going to be this one, although it's lengthy, it's very repetitive, as we'll see. Assume a variable S name always contains the first two names of a student followed by their surname. Okay, so I've got Mary Teresa Poppins. Okay, note one space between each. Okay, so so that's making it consistent. Write code to generate the initials followed by a space and their surname, for example, MT Poppins, and store it in a variable called SNew. Okay, again, here we go back to we say, right, in real life, how difficult is this? I give this to you in a test, and I'll say, write down the initials and surname of the person. You'll say, okay, the teacher's lost the plot, but I'm quite happy to do that. What has actually happened? You've located the first name. Okay, and you located the first name because it was followed by a space. Your eyes and brain are working at such immense speed, you don't even realize you're creating an algorithm. Okay, but we've got to tell the computer step by step how you would go about it. So, right, so you said, okay, there's the first word because it occurs just before that space. Okay, if that's the first word, then that'll give me the M. Okay. And then you basically discarded it because you said, right, well, I've got the M now. I don't have to worry about it. So let's just do it again. I've got the M already, so I've written that down. Let's do the same thing again. Here's another space. Okay, so that's the name there. So that's T. It's the first character in the T. And I say, right, well, now I've got the M and the T. And then I just sort of discarded the rest of it and say, oh, okay, the surname is Poppins. So it's MT Poppins. Okay, so we did that all in our brains so quickly without even realizing what we were actually doing. No, we totally realized what we were doing, hopefully. Okay, there we go. Right, so write code to generate. So I want to get empty space Poppins coming out. Okay, I want to get empty space Poppins coming out. Okay. My first thoughts on, and the problem is sometimes, and the reason why I went to that as a specific human algorithm, if I could put it that way, is that it's so important not to think in Delphi. After a while, you can sort of think in a crossover between problem solving in Delphi or whatever programming language you're using. But remember that whatever programming language you're using or whatever program you're using to implement, because you could do this in Excel as well, actually probably easier in Excel. But you've got to say, what are the steps that have been followed? Because whatever program you're using is just the means of implementing the solution. Okay, it isn't the solution. It ends up being the implementation of the solution, but the actual solution has its origins in the algorithm, the way that we solve this thing. Okay, so now I could start to think, although admittedly some of you would probably think, oh, wait a bit, there's a space there. I can find a space and I can get the first. Okay, so yeah, it does creep into you as you get better and better with the Delphi, and that'll improve with time, as with any programming language that you will encounter in the future. So I want to say, right, I want to find that first space. Okay, I want to find that first space. Well, do I need to find the first space? That's actually interesting. Do I need to find the first space? No, I don't, because well, not immediately anyway, because what's the first character? The first character must be the first initial. So I've just put it into variable SNew. I've just copied the first name Mary out. Okay, so that was handy. I've got the first character already. Now, am I interested in the rest of the sentence? What am I not interested in more? I'm not interested in that part anymore. Okay, I'm not interested in this part anymore. Okay, the Mary in the space. I want to get to Teresa. Okay. Right, well, now I can possibly find that space. And say, right, the positive position in the space is, okay, it'll find the first one. So M-A-R-Y is the first space. Okay, remembering that I've already copied M for Mary into this. So this is now a 5. Okay, so 5 in this case. That obviously works for any example. So it's 5 in this case. Okay, so I want to delete everything up to including position 5. I don't want the space. I'm not interested in that. I actually just want to work with Teresa Poppins now. I don't want to work with Mary space anymore. Okay, so that's fine. So I'll delete it. I'll delete from that character. Right, now that I've got the M and Mary, I'm really not interested in everything about Mary, shame. But so I want to just delete that. So I found the position of the first space. That's fine. And remember, that's what pos does. It finds the position of the first space, not the second space. It's not capable of doing that. And I'm just going to delete everything. So that says, so that was a 5. So it says delete from position 1, 5 characters. So it takes out the M, the A, the R, and the Y, and I'm left with that. So now I'm left. And now I can easily get the second initial because, why? Well, because it's the first character again now that I've deleted the rest of it. So I can add that on. So S new, remember that was M for Mary. I now add on the second initial, in other words, the T. Okay, I add on the second initial, the T of Teresa. Okay, so it becomes MT now. Okay, not empty, but you get the idea. Right, now that I'm now not interested in Teresa anymore. Okay, I'm very fickle by the sounds of it. Okay, so I take this, I need to take the space, and I'm only interested in Poppins. That's actually all I'm interested in now. Okay, I'm interested in Poppins now. So let me find, I said the last space. In fact, it's the only space that's left now. Okay, so that space is at where? 1, 2, 3, 4, 5, 6, 7, 8. It's in the 8th position. Okay, and let's just delete everything that's there. So I'll delete 8 characters. So that's all of Teresa plus the space. Now I'm just left with Poppins, which I am interested in. Okay, and I can just add it on. And I can just add it on to the new string. Okay, please note that I actually added a space there as well, which because I just wanted it to be nicely spaced when I printed it. Didn't want it to be empty Poppins, I wanted it to be empty space Poppins. So there I've just added on what's left, and what was left was the actual Poppins. So it's just a repetitive thing that I've gone over and over again. So and you can do it. Doesn't matter how long the string is. You're basically going to be finding this, deleting this, copying this, finding this. But again, go back to the actual example and say, right, let me work as an example. If they don't give you one, which is unlikely, work with one and say, okay, what am I doing? I'm finding the space. Then I'm taking the first character out. And then I'm deleting everything, including the space, which I know because I've got the position of the space. And then my string looks like this. Okay. And so that's the way that you work, and then you translate that into Delphi. If you start to write this in Delphi, you are a little bit screwed. Okay, in terms of your approach. After a while, you tend to write it almost without thinking, but that takes a bit of practice still, and it's not always advisable in any case.